All right, so the second lecture, kind of a pre-calc equations chapter. We run into problems that have radicals in them, and to get this to work, we're going to have to isolate the radical. So anything that's on its square root, we're going to isolate that. So the easiest is to add the x to the other side. And you have a positive x and a positive 2. So now I'm able to square both sides, and squaring the square root will just undo it, if you will. They're inverse operations. And then if you still need to FOIL or do the box method for this, do so, but you get x squared plus 4x plus 4. And I like to have everything on the x squared side, so I'm going to subtract 2x. And I'm going to subtract 7. So the nice thing is my quadratic now is equal to 0. So I could go into the quadratic formula. I can do completing a square, but in this case I could even factor it. So this one would factor into x plus 3, x minus 1. And then you can take those two factors and set them equal to 0. And I get x is negative 3. Add 1 to both sides. I get x is 1. So I have these answers. And again, we have to be really careful in this problem because back here, I kind of draw an arrow off to the side. That term right there, that is created by us. We use rules of algebra, but now that allows for positive or negative, so that allows for a second answer to be the same. And so we need to check for extraneous solutions. So I'm going to take the negative 3 and plug it back in. And so it's going to look like 2 times negative 3 plus 7 minus negative 3. And we're supposed to see if that equals 2. So right here, we have negative 6 plus 7, so that's the square root of 1, plus 3, and the square root of 1 is 1, so does 1 plus 3 equal 2? No. So that's called an extraneous solution. And if I do the same thing with the 1, I can do 2 times 1 plus 7, subtract the 1, and see if that's equal to 2. So right here, I end up with 2 plus 7 is the square root of 9. And square root of 9 is 3, so does 3 minus 1 equal 2? Yes. So this one does work. So you find two solutions, one's extraneous. So now you're going to pause the video and try example number 2. So pause it now. All right, coming back to it now, you have get the square root of x minus 10 by itself, add the 5 to the other side, square both sides, and in this case, all you're going to have to do is add the 10 and you get 26. And when you plug that back in, 26 minus 10 is the square root of 16, which is 4, and 4 minus 5 does equal negative 1, so that works. So now we have an example with two radicals. So let's take the negative 1 to the other side, and we're left with 2x plus 6 is 1 plus, now it's positive, radical x plus 4. So with two of them, you're not going to be able to get them both isolated at the same time, so get one of them. Now I'll square both sides, so I'm left with just 2x plus 6. But this one's a little different, so I'm going to walk you through it. So obviously 1 times 1 is 1. And this radical right here gives me just x plus 4. But when you do the OI, you get x plus 4 under that radical, and you get another, these kind of look like eyes, they're not eyes. And now you get another square root of x plus 4. Well, I have one here and one here, so I have 2 of those x plus 4s under the radical. So now you need to get that one by itself. So I'm going to subtract 1. I will subtract x, and I will subtract 4. So this is x plus 1. This is gone, this is gone, this is gone. And then I always ask, there's a 2 here. Would it help to divide over here by the 2? And I would say no, it kind of makes this messy. So I'm going to leave it where it's at. And now we're going to square both sides again. And this would be x squared plus 2x plus 1. And this one again, you end up, I forgot to write squared. We forgot to write squared. So now you have 2 times the square root of x plus 4 times another 2 times the square root of x plus 4. So why not multiply these two together and get 4, multiply these two together and get x plus 4, and then distribute the 4 and you get 4x plus 16. You get to choose when you have 4 things what order you multiply them in, but it is not distributive property. You don't take the 2 times everything. Just pick 2, multiply them, pick 2, multiply them, and then multiply the answers. So you're going to have 4x plus 16. We will subtract 4x, because again, we're working with the quadratic. Subtract the 16, and we always want that quadratic to be equal to 0. So you have x squared minus 2x minus 15. That will actually factor nice into x and x minus 5 plus 3. So if you set those two equal to 0, you're going to get 5 and negative 3. And of course, we should plug them back in. And so when you plug in the 5, I'll just walk you through it. That's 10 plus 6. So the square root of 16 is 4. So remember, we're doing 5. And 5 plus 4 is 9. So the square root of 9 is 3. So I end up with 4 minus 3. And that does equal 1. And then if you try the negative 3, put the negative 3 here. 2 times negative 3 is negative 6. Plus 6 is 0. So the square root of 0 is 0. And then negative 3 plus 4 is 1. Square root of 1 is 1. So you end up with a statement like that. Well, that is a no. So the negative 3 will not work. So when you look at the next example, it actually works out just a little bit easier. You'll see why, but pause the video now. So both radicals are positive, so it won't matter which one you move to the other side. I move the x, square both sides. So here you get x minus 20. Over here, you're foiling or box method, you'll get 100 minus 20x, root x for the middle term, and an x over here. But because there's an x here and an x over here, when you subtract from one side, they're gone. And you can see right here, this is what you're left with. And then this time I say, does it help to divide by negative 20? Sure it does. So when you divide, you end up with the 6 and the square root of x. So now when you square both sides, you get x is 36. And you can see over here that it checks, and that one answer does work. So in this next example, we're working with a rational exponent. And remember, rational exponent means that the exponent is a fraction or can be written a over b. So you have a number base being raised to the power on top the root on the bottom. So right there, that's the power. And you want to really pay attention to the number, because a power, remember, if we take away the even power, we have to put plus or minus in. So we're going to raise this to the 3/2 power on both sides, and you end up with x plus 1. So when you stack exponents up, you multiply. So 2/3 times 3/2 is 1. And I don't need to write something to the power of 1. So I undid the exponent, and over here I will have 4 to the 3/2 power. But we have to remember to put plus or minus, because this was an even power and we took it away, put the plus or minus back in. Now on my calculator, I can go in and go ahead and take, you can see how I typed in 4 to the 3/2 power, and I get 8, because you're cubing it and then square rooting it, or square rooting it, then cubing it. It won't matter. If some of you have calculators where it does 4 and you get the little caret symbol, make sure you put the 3/2 in parentheses before you do this. So now we have x plus 1 is equal to plus or minus 8. So we're going to subtract 1 on both sides. So x will be -1 plus 8 and -1 minus 8. So this will be 7 and this will be -9. And if you plug those two numbers in on your calculator, you will see that when you raise that to the 2/3 power, it will equal 4. So try the next example and go ahead and pause the video and come back to check the answer. So pause the video now. Okay, so when you work on this one, you'll notice that the power right here, that's an odd number. So if you would raise it to the 2/3 power on both sides, so if you do the 2/3 power, you are getting rid of an odd power, and we do not have to worry about plus or minus when you get rid of an odd power. So the number on top, right, is odd. So now when I do this, you can go to your calculator, and what you're going to get is this 5. But what you're looking at here, somebody did it a little bit different. They wrote it out, and then they did it piece by piece. But x minus 1, you add the 1 to both sides, and it's equal to 5. So if you plug that back in, 5 minus 1 is 4. Square root is a 2, and cube it is 3, so it did work.